Mesh analysis. This is one among the analysis techniques. We will have a look at this mesh analysis. So the objectives of this video is define mesh and what is a loop, and in the given circuit identify the number of meshes, and applying KVL and solving the mesh equations and finding various currents and voltage drops across various components, and understanding the mesh analysis technique little more thoroughly with the various examples of the different circuit elements as well as sources. So before that we need certain fundamentals. So like electric network, what is the branch, what is the loop, and what is the mesh. So a network is said to be completely solved or analyzed when all voltages and all currents in its different elements are determined. Alright. So what is an electric network? It's a combination of various electric elements connected in any manner whatsoever is called an electric network. The network may be a passive network, may be an active network. Active network will have one or more than one source of EMF, and passive network will have only passive components. They will not have any EMF or active components. So branch is another term. Branch is a part of the network which lies in between two junctions. So coming to the next one, loop. Any closed path is called as the loop. A closed path that will not have any closed paths within it is called as mesh. Mesh is a loop that contains no other loops within it. So that's called as mesh. So there is a slight difference between mesh and the loop. Mesh is a subset of loop, but loop is not the subset of mesh. Every mesh is a loop. Every loop need not be a mesh, right? So any closed path is a loop. A closed path that contains no other closed path within it is called as mesh. So take this example: A, B, C, D. They are the junctions. They are the nodes. NODE node. So here A, B, C, D, A. This path is called as closed path. So A, B, C, D, A is a loop, whereas A, B, D, A is one mesh, B, C, D, B is another mesh, right? Coming to the next one, so that is there are certain steps which are involved in the mesh analysis technique. In that, first we have to identify the number of meshes in the given circuit, and then we have to assume the current components in various meshes, like I1 in the first mesh, I2 in the second mesh, I3 in the third mesh, like that, and so on. Take an example of 1. In this, A, B, C, D, A is a loop, whereas meshes are 2. The first mesh is A, B, D, A. The second mesh is B, C, D, B. This closed path is also called as a mesh, right? So now A to B, B to D, A to B, B to D, D to A. This path is called as this closed path, and this is called as one mesh. Now take an example. In this example, we are assuming the current components in single mesh. So I1 is the current in the first mesh, I2 is the current in the second mesh, right? So now take another example. In this circuit, there are three closed paths are there, three meshes are there. So we write the closed paths like this: A, B, C, A is one mesh. Next one, A, D, B, A is the second mesh. B, D, C, B is the third mesh. So likewise, there are three meshes are there. The three meshes and the paths are first mesh path is A to B, B to C, C to A. And the second mesh path is A to D, D to B, B to A. Third mesh path is B to D, D to C, C to B. So these are the three meshes available in this example. Consider the current components I1, I2, I3 in all the three meshes. I1 is the current in the first mesh, I2 is the current in the second mesh, I3 is the current in the third mesh. Now coming to the third example, in this three meshes are available and the paths are A to B, B to C, C to A is the first mesh. A to D, D to B, B to A is the second mesh. B to B to D, D to C, C to B is the third mesh. Right? Let us assume the currents in three meshes like I1, I2, I3. I1 is the current in the first mesh which is going in the clockwise direction. I2 is the current we are assuming the second mesh which is also flowing in the second mesh in the clockwise direction. And the third one, I3 is the current flowing in the third mesh in the clockwise direction like this. And but in this particular problem there is a constant current source available in the path DC which is 3 amperes. So the current in this particular branch is minus 3 amperes. As we go from D to C, it is opposite to the direction of this flow. So it is minus 3 amperes. But if you consider the path direction from C to D, then it will be 3 amperes. So step number 3 is apply KVL, Kirchhoff's voltage law, in individual mesh and we'll get equations. And one more very important thing is all these mesh equations are the functions of I1, I2, I3 and so on. In the mesh analysis, we need to find the value of I1, I2, I3 and so on only. The main concept in the mesh analysis is to find the currents available in various meshes. They are the unknowns, right? And we know Kirchhoff's voltage law. According to this particular law, the algebraic sum of the products of the current and resistances and EMFs in a closed path is equal to 0. So that is starting from a particular point, if we go around a mesh till we come back to the starting point, if the algebraic sum of the current into resistance plus EMFs in a closed path is 0. So that is the KVL, Kirchhoff's voltage law. Kirchhoff's current law is also there. In this context, we don't use Kirchhoff's current law. We use Kirchhoff's current law in nodal analysis. Now there are certain sign conventions that we have to follow in order to write the KVL equation. When you consider an EMF source and your path is from A to B, then when you're going from A to B and the current direction is also same, that is irrespective of the current direction, when the path direction is from A to B, so we consider minus to plus as minus. Now in the same way, when the path is from A to B and the first terminal that you come across is plus, then we consider plus to minus as plus, minus to plus as minus. So here minus to plus, that is minus, and plus to minus, that is plus. So whereas if you consider resistor IR drops, so the path direction and the current direction both are important. If both are same, then we consider plus. If both are opposite, we consider negative. For example, in this, the path direction is A to B, the current is also going from A to B, then I into R1, I into R1, that is that. Now coming to the next one, if in this particular example, the path direction is from A to B, but the current is opposite to the path direction. So it is minus 5 volts, in the sense if the resistance is something, and current is I into R1, minus I into R1. So we will see the example. And we apply this KVL in analyzing and getting various parameters in the next video.